Bismillahirrahmanirrahim. Assalamualaikum and welcome back to my YouTube channel Maths with Samreen. In this video, we will discuss what is simplex method and what steps we should follow in order to solve a linear programming problem using simplex method. Starting with the definition of simplex method. What is simplex method? It is a popular algorithm for solving linear programming problems, and it is a powerful technique for finding optimal solutions to a linear programming problem. Three different conditions can occur for a simplex method. Number one is feasible solution, number two is infeasible solution, and number three is degeneracy for both maximization and minimization cases. The case and the condition we will be discussing today is maximization and feasible solutions. Let's take an example to understand it further. Please grab a paper and a pen and work through the solution with me. It will help clarify your understanding. Okay, so here is an example. The objective function is maximum of z is equals to 100x1 plus 80x2 and subject to constraints are 6x1 plus 4x2 is less than equals to 7200 and the second is 2x1 plus 4x2 is less than equals to 4000. Okay, so step number one is that we have to introduce the slack or also called surplus variables to these equations. That is equation number 2 and equation number 3. There are two cases that we should keep in mind that if there is a less than equals to sign in these equations, we add the surplus variables or also called the slack variables. And if there is a greater than equal to sign, we subtract the slack variables in these equations. As you see, there is a less than equals to sign in equation number 2. So we add a slack variable in it and it will become 6x1 plus 4x2. We have to add a slack variable, so we use a plus sign here and write s1. This less than equals to sign changes into an equals to sign and the solution here will be 7200. Let's say this is equation number 4. Also, there is an again less than equals to sign, so we use 2x1 plus 4x2 plus s2 here because we have already used s1 sign here, so we use an s2 sign here and write equals to sign and write the solution. That is 4000, and let's say this equation is equation number 5. We also have to add the slack variables in our objective function with 0 as its coefficient. So adding the slack variables in our objective function, we get maximum of z is equals to 100x1 plus 80x2 plus 0s1. Why I used a 0 here? Because it's the step that we have to write a slack variable with 0 as its coefficient in the objective function. So it is very important to write 0 here. And other variable we have used is s2 and it will become 0s2. Now we further simplify it and it will become z minus 1000 x1 minus 80 x2 minus 0 s1 minus 0 s2 equals to 0, and name this equation as equation number 6. Why? There is one important thing that you have to keep in mind, that if there is already an equals to sign given in the constraints, you don't have to add or subtract any surplus or slack variables in that constraint. And one thing that we have to write in the constraints is that x1, x2, s1, s2 are greater than equals to 0. Now we have to fill this table by using the coefficients in these equations. We take x1, x2, s1, s2 solution, and this is minimum ratio, and then here is z. Z is the objective function. We have to fill this table with the coefficients of corresponding x1 in z, x2 in z, and s1, s2 and so on. And so from z, here the coefficient of x1 is minus 100. Also write the signs here, and for x2 the coefficient is minus 80. S1's coefficient is 0. You see, this is why writing a 0 is very important here, because if there is no 0, it will make the coefficient of S1 as 1. So that is why we use a 0 sign here, so that its coefficient is 0 and the coefficient of S2 is also 0. The solution here is 0, that is on the right side of the equation 0. Let's leave it for now. Now by using equation number 4, the coefficient of x1 is 6 here and x2 is 4, s1 is 1, there is no s2, so the coefficient of s2 is 0 and the solution is 7200. And similarly from equation number 5, we get the coefficient of x1 as 2, x2 as 4. There is no s1 here, so the coefficient of s1 is 0 here and s2's coefficient is 1. And again the solution is 4000. Now we have to select the reference column. For that purpose, look for the minimum negative value of z, which is negative 100 here. Why minimum negative value of z? Because we are dealing with the maximization case here. So as minus 100 is the minimum negative value here, so we lock this column. Now we have to calculate the minimum ratio. Now to calculate the minimum ratio, divide the value of this solution, that is 7200, by this value, by 6. And also here it will be 4000 divided by 2. We do not calculate a minimum ratio for z here. And here the value will be 7200 divided by 6 equals 1200 equals 2000. Now we have to choose a minimum value from both of them. So the minimum value is 1200 here. We lock this row. Now we have to write entering variable and the leaving variable. That is our step number 3. The entering variable will be the less negative value in 0, and the less negative value in 0 is minus 100, and it is the coefficient of x1. So the entering variable here will be x1. And the leaving variable will be the minimum ratio value, and the minimum ratio value is 1200 and it's corresponding to S1 row. So the leaving variable here will be S1. Now we simply replace the leaving variable with the entering variable. So the leaving variable is S1, we replace it by X1. You can also write it like this, or you can also form another table for this purpose. But writing it like this will save your time. Okay, so step number 4 will be make 1. What? The value present at the intersection of x1 and x1. The intersection of x1 and x1 is this, and the value present here is 6. We have to make it 1. So if we divide this term by 6, it will give 1. But note that whatever operation you apply to that term will be applied on whole row. So the operation we will apply is x1 divided by 6, where x1 is the row and 6 is the term that we use to get 1 here. So dividing x1 by 6, we get 6 by 6 equals 1, 4 by 6 equals 2 by 3, 1 by 6, 0, and 7200 divided by 6 gives 1200. Do not apply this operation on minimum ratio. Now write a new table with the new entries of x1 you get. You don't have to write the minimum ratio column here. Apply the row operations to make all other entries of this column 0 except this. Okay, so before solving it further, let me tell you something about the row operations. That is, the row getting changed is written at the first. See, we have to change the row z here. We have to make 0 here. So we write z first, then write plus minus, and then we use the row which is used is written after it. So we are using the row x1 to alter z. So we use x1 here. Now set it accordingly. That according to your situation, you need a 0 here and there is negative 100 here. You have to add 100 in it so that it will become 0. And for that purpose, you have to first multiply this x1 with 100. So z, the value of z is minus 100 and plus minus operation, and if you multiply x1 with 100, now see which sign suits our situation. It is a negative 100. If we add a 100 in it, it will become 0. So we will simply use a plus sign here. That will give us 0. So the row operation will be z plus 100 into x1. Now you have to apply this operation on this z row. To avoid any mistake, I suggest you to follow these steps in the rough work. That is, first write the complete row z, which is minus 100, minus 80, 0, 0, 0. And then multiply 100 by the complete row x1, which will give 100 into 1, 100, 2 2 by 3 into 100 gives 200 by 3. 1 by 6 into 100 gives 50 by 3 after simplification, and 0 into 100 gives 0. 1200 into 100 gives 1,20,000. Then put the sign you're using in the operation here and solve it like a sum. So minus 100 plus 100 gives 0, minus 80 plus 200 by 3. Use a calculator to solve this term, and this will give minus 40 by 3. 0 plus 50 by 3, it will give 50 by 3. 0 plus 0 will be 0, and 0 plus 1,20,000 equals to 1,20,000. Now replace these entries with the 0 here. It will give 0, minus 40 by 3, 50 by 3, 0, and 1,20,000. As I'm using a whiteboard, so I rubbed the previous entries and simply wrote the new entries here, but you have to write a new table for this step. The row operations that we have applied up till now are x1 by 6 and z plus 100 into x1. But we are not done yet. We have to make 0 here as well. So the row that is getting changed is S2. Then we apply a plus minus sign and we are using the row x1. As you see, there is a positive 2 element here and we have to make it 0. For that purpose, we must have to subtract 2 from it. And by using the row x1, we will first multiply the row x1 by 2 and then we subtract both of them to get 0 over here. So the row operation will be S2 plus minus. First we have to multiply 2 with x1 as there is previously a positive sign here and we need a negative sign here to subtract them to get a 0. So we simply just remove the plus sign and the final row operation will be S2 minus 2x1. So the third operation that we are using is S2 minus 2x1. Again, to avoid any mistake, solve this term in the rough work as I did here. First write S2. It will give 2, 4, 0, 1, 4,000. Simply I wrote the S2 row here. Then I have multiplied 2 with x1. So here is x1. 2 into 1 will give 2. 2 into 2 by 3 gives 4 by 3. 2 into 1 by 6 gives 1 by 3. 2 into 0 gives 0. And 2 into 1200 gives 2400. Then we have to apply a negative sign here and then subtract these terms. It will give 2 minus 2 equals to 0. 4 minus 4 by 3 on the calculator it gives 8 by 3. 0 minus 1 by 3 gives minus 1 by 3. 4000 minus 2400 gives 1600. Replacing the previous entries of the row S2 with the new entries, we get 0, 8 by 3, minus 1 by 3, 1 and 1600. The first iteration ends here. Now we have to check for the stopping criteria. Let's discuss the stopping criteria. As we are dealing with the maximization case, so as long as we are having a negative value in this row, which is 0, so we will repeat the iterations. As you see, there is one other negative value in the 0, which is minus 40 by 3. So we have to repeat the same procedure. So now we have to select a reference column and you see there is only one negative value in row Z, so we lock this column. And also we have to write minimum ratio here. So the minimum ratio will be 1200, which is the solutions value, divided by 2 by 3, which will give 1800, and again 1600 by 8 by 3 gives 600. As the criteria for selecting the minimum ratio value is that we have to select a finite positive minimum value, which is 600 here. So we lock this row. And now we will select the entering variable and the leaving variable. As explained earlier, the entering variable will be x2 and the leaving variable will be s2. So we cut s2 here and write x2 here. The value present at the intersection of x2 and x2 is 8 by 3. We have to make this entry 1. To make a 1 here, you have to multiply this term by 3 by 8. That is 8 by 3 when multiplied by 3 by 8 gives 1. Note that you have to apply this operation on the complete x2 row. Now write a new table with the new entries of the row x2 that we got after multiplying the previous row x2 by the term 3 by 8. So the new row x2 is 0, 1, minus 1 by 8, 3 by 8 and 600. Okay, so now first make this term 0 using this row. As you see, there is a term minus 40 by 3. So if you add the term 40 by 3 in this term, it will give you 0. For that purpose, you have to multiply this term by 40 by 3 as I did here. And as you see, there is already a negative sign here. So we need a positive sign here to make it 0. So this will be our row operation. Minus 40 by 3, which is the value of z here. Then we add it, and 1 is the value of x2, and 40 by 3 will give minus 40 by 3 plus 40 by 3 equals to 0. Note that you have to apply this operation on the complete row z. So by applying this row operation on the row z, we get 0, 0, 15, 5, 1 lakh and 28,000. In the next step, you have to make this entry 0 as well. For that purpose, we will be using this row, and you see there is a term 2 by 3. If we subtract a term 2 by 3 from this, it will give us a 0 here. Our next row operation will be x1 minus 2 by 3 into x2. So by applying this row operation to the row x1, we get the new values of x1 as 1, 0, 1 by 4, minus 1 by 4 and 800. Now we have to check for the stopping criteria. As you see, there is no more negative value in the row z. And also both the variables s1 s2 are removed from here or replaced by x1 and x2. So the stopping criteria is fulfilled and optimal solution is obtained, which is z is equals to 1,28,000 and x1 is equals to 800 and x2 is equals to 600. So this was our today's lecture. I hope that you understand it. If you have any query, you can ask me in the comment section. We'll meet you in the next video. Till then, Allah Hafiz.